Hello students, this is Mr. Haney, and in this short video I'm going to show you how to solve some problems using Boyle's law, Charles' law, and Avogadro's law. So in this first sample problem, it says a container is filled with helium gas. It has a volume of 3.25 liters and contains 2.50 moles of helium. What would be the volume of a container that held 7.50 moles of helium at the same temperature and pressure? So I see that I'm dealing with volume and number of moles, so that tells me that I need to use Avogadro's law. And so I'm going to have 3.25 liters over 2.50 moles, and that equals an unknown volume over 7.50 moles. So to solve this, I can just cross multiply and then divide. And so when I cross multiply, I get 24.375 equals 2.50 times my unknown volume. And so I can just divide both sides by 2.50. And my unknown volume is 9.75 liters. So that's my answer, 9.75 liters of helium gas. So in this next sample problem, it reads, a container is filled with helium gas. It has a volume of 4.00 liters and is at a temperature of 25.0 degrees Celsius. What would need to be the volume of a container that contains the same amount of helium gas at the same pressure at a temperature of 50.0 degrees Celsius? So I'm talking about volume and temperature here, so that means I'm going to use Charles' law. But there's one important thing that I have to do first. Whenever I'm solving any gas law problem, I have to first convert any temperature that I have into Kelvin. So this is kind of a trick. It looks like it went from 25 to 50 and it doubled, but it did not double because we don't use Celsius for our gas laws, we use Kelvin. So I have 25 plus 273 to convert it into Kelvin, and so that temperature should be 298 Kelvin. And then this 50 degrees Celsius plus 273 gives me a new temperature of 323 Kelvin. So now I can plug in my numbers and solve my problem. So I have 4 liters over 298 Kelvin. That equals my unknown volume over 323 Kelvin. So once again, I can cross multiply and then divide. And so that gives me 1292 equals 298 times my unknown volume. And when I divide both sides by 298, I see that the volume here would be 4.34 liters. And I rounded that to 3 significant figures. So this is the correct volume that it asked for in this problem. And in the last practice problem, it says a collapsible container is filled with hydrogen gas. It has a volume of 5.0 liters and a pressure of 3.0 atmospheres. If the pressure of the container is increased to 7.5 atmospheres without removing any of the gas or changing the temperature, what will the new volume be? So I'm working with pressure and volume here. So that means I'm going to use Boyle's law. And so I have 3 atmospheres at a volume of 5 liters. And I'm going to increase that to 7.5 atmospheres. And I need to know what that new volume would be. So I can just divide both sides by 7.5. And so 3 times 5 divided by 7.5 gives me a volume of 2 liters. So that's all there is to selecting the correct gas law and then just plugging in the numbers and solving for your unknown. Just make sure that you convert any temperature from Celsius to Kelvin. Keep up the great work. I'll see you next time.